mathematics, what does expanding brackets mean? We're going to look at expanding one pair of brackets and then look at the product of expanding two pairs of brackets. Is this what expanding brackets means? Of course not. Let's have a look. Basically, in mathematics, to expand brackets means you remove them from the expression you are using, and that involves multiplication. Here we have a ruler. Let's suppose we mark off 1 centimetre and also mark off the next 3 centimetres. If we double the total length, that will give us 8 centimetres, won't it? Let's write that down using numbers. We're adding the 1 centimetre to the next 3 centimetres, which of course means 1 plus 3, which gives us 4. And then when we double that, we have 2 times 4, which is 8. Another way of writing that is to double each of the individual lengths first and then find their sum. So we can write 2 times 1 plus 2 times 3. That gives us 2 plus 6, which of course is 8, the same as the first method. And yet a third way is to look at it in this way. We are doubling, that's where the 2 comes from, and we are multiplying that by the sum of the individual lengths, 1 plus 3. And to show that we are doubling all of that, we put that expression in brackets, as shown there. Now in mathematics, a number or a quantity immediately in front of the brackets always implies multiplication, so we do not need to show that. So we can write that as 2 bracket 1 plus 3. And using our answer from earlier, we can say that 2 bracket 1 plus 3 is the same as 2 times 1 plus 2 times 3. So just using a few numbers, we've shown that expanding brackets, in other words removing them or getting rid of them, gives us, as you can see there, 2 times 1 plus 2 times 3. We can extend this to the general case. Let's suppose A, B and C are any 3 numbers. Then if we follow the method that we've just found, we can write A bracket B plus C when expanding the brackets will give us A times B plus A times C. Now here are some examples of that. Again, using just numbers, we have 5 bracket 4 plus 7. Expanding the brackets, we have 5 times 4 and then 5 times 7. And working each of those parts out, 5 times 4 is 20 and 5 times 7 is 35 and the sum is 55. Another example, this time we introduce letters or variables or pronumerals. We have 3 in front, so we have 3 bracket A plus 2B inside the bracket. But again, following exactly the same method, we can write 3 times A plus 3 times 2B. Now simplifying that, we can write 3 times A is 3A. The times does not need to be shown, it's implied in the expression. And 3 times 2b, 3 times 2 is 6, so it becomes 6b. Next one, 2b in front of the brackets and then inside 6a minus 5b. So following the same method again, we have 2b times 6a. Notice there's a minus in the middle now. And 2b times 5b. Simplifying, 2b times 6a. 2 6s are 12, and b times a we can write as ba. And 2b times 5b, 2 5s are 10, and b times b we write as b squared, or b to the power of 2. So there's our final answer. So far we've had 2 numbers, or 2 terms as we call them, inside the brackets. But we can look at the general case. That means we have more than 2 terms inside the brackets, as you can see there. Let's say we have the pronumeral A in front, and inside the brackets we have n terms. In other words, b1 plus b2 all the way up to bn, where n is the number of terms. So if n was 10, then we'd have 10 terms inside the bracket. But again, the method of expansion is exactly the same. We multiply each term inside the bracket by what's in front, in this case a. So the answer becomes the expansion a times b1 plus a times b2 plus a times b3 and so on, all the way up to a times bn, which would be the last term. And some examples of that: in this one we have 3 terms inside the bracket, so we can write as the expansion 4 times 5c minus 4 times d plus 4 times 7e. And now simplify. 4 times 5 is 20, so we have 20c. 4 times d is just 4d. And 4 times 7 is 28, so it becomes 28e. So there are 3 terms in the expansion. Another one, 2ab in front of the bracket, and again 3 terms inside. So we start by saying 2ab times 3a. Now let's see if we can do that in one go. We have 2 times 3, which is 6. We have a times a, which we can write as a squared. We have b as well. So the expansion of that first part is 6a squared b. The next part of the expansion, 2ab times 4ab squared. We can have 2 times 4, which is 8. A times a, which is a squared. And b times b squared, which gives us b cubed, or b to the power of 3. And finally, expanding the next part, 2ab times 5b, we have 2 times 5, which is 10. A times a is there on its own, and b times b is b squared. Okay, so we've dealt with one pair of brackets. Let's see the situation for 2 pairs of brackets. And in this case we are taking the product. Product means multiplying. So we are going to be multiplying 2 pairs of brackets. Just as we did with one pair of brackets, let's use numbers to see what's happening. So let's suppose we're going to expand 2 plus 3 in one bracket and 4 plus 5 in the second bracket. Remember, product means multiply, so there is a times in between the 2 brackets, even though it's not shown. Before we expand it using our method, let's just work out the answer. The first bracket gives us inside 2 plus 3, which is 5, and the second bracket 4 plus 5, which is 9. And 5 times 9 is 45. So we know the answer will be 45. Now let's have a look at it another way. We'll multiply out 2 times 4. That means the first term of the first bracket times the first term of the second bracket. And then 2 times 5, the first term of the first bracket multiplied by the second term of the second bracket. And then 3 times 4. And finally 3 times 5. You can see that there are 4 terms in the result. And we can simplify each of those. 2 4s are 8. 2 5s are 10, 3 4s are 12, 3 5s are 15. And the sum of those 4 numbers, 45, which is the answer that we obtained just working it out directly. So do you notice a pattern in the expansion of those 2 brackets? Can you see the order in which we perform them? We'll look at the general case and maybe the method will become a bit clearer. So let's call our 4 numbers A, B, C, D. A and B in the first bracket, C and D in the second. If we follow the method of expansion that we used in the previous example, we will have A times C, A times D, B times C, and B times D. And just to highlight that, there's our general formula. Remember, multiplication between variables or pronumerals is always implied, so we don't need to show it. Can we relate this expansion to some practical context that we can appreciate? Yes, we can. And we can do that in terms of the area of a rectangle. Let's suppose we have a rectangle and the width is made up of 2 parts, C and D, 2 lengths, and the length, of course, made up of 2 parts, A and B. The area of a rectangle is found by working out the length times its width. Now, what's the length of that rectangle? The length is A plus B, isn't it? And what's the width? C plus D. So the area will be length times width, which is bracket A plus B times bracket C plus D. And of course we don't need to show the multiplication in between the 2 brackets. So the area of the rectangle is bracket A plus B, bracket C plus D. Now, another way of finding the area of that rectangle is to work out the sum of the areas of smaller rectangles and squares, as you'll see now. There's a rectangle made up of the length A and width C, and the area is A times C. There's another rectangle, length B, width C, so the area is B times C. Another rectangle, length A, width D, so its area is A times D. And finally, a rectangle with length B and width D, so the area is B times D. So the total area of those four rectangles is what you can see there at the bottom of that screen. And of course, the sum of those has to be the sum of the original whole rectangle. So you can see that that confirms our expansion formula that we obtained previously, where we obtained the four terms. Now, the product of two brackets has two special cases that we can look at. In the first case, let's suppose that variables C and A are the same and variables D and B are the same. That means in our formula, and that's our formula there, we can replace the C by the letter A and the D by the letter B, and that's what it would look like. And on the right hand side, with the same replacements, that's what we have. And just simplifying that, A times A is A squared. Now the two middle terms, we have A times B, which is AB, and B times A, which is BA or AB. We've got two of those. We can join the middle two terms and write them as 2AB. And at the end we have B times B, which is B squared. So this is what it means. When we have two brackets the same, that we are taking the product of, the expansion becomes A squared plus 2AB plus B squared. And another way of writing A plus B times A plus B is to write it as bracket A plus B squared. And that is called a perfect square. Can you see why? Because it represents a square, because it represents the area of a square rather than the area of a rectangle, because both the length and the width are the same. In this case, A plus B. The second case is where we let C equal A and D equal negative B. And if we make the replacements in our formula, that's what it looks like. We have A plus B in the first bracket and A minus B in the second bracket. And expanding that, using the substitutions, we have on the right hand side, as you can see, A times A minus A times B plus B times A minus B times B. Notice that the two middle terms, minus A times B and plus B times A, cancel out. They are opposites. So all we have left is A times A, which is A squared, and B times B, which is B squared. And that is also given a special name, where the two brackets are exactly the same except that one has a plus in the middle and the other has a minus. And that is called the difference of two squares. Can you see why? A would represent a square of side length A, and B would represent a square of side length B, and difference in mathematics means minus, take away. So difference of two squares. You're basically representing the difference in the area of two squares. You're subtracting one area from the other. And here's an example. 4k plus 3 in one bracket, 4k minus 3 in the second bracket. If we replace all occurrences of A with 4k and all occurrences of B with the number 3, that's what it looks like. And 4k squared means 4k times 4k, which is 16k squared. 3 squared means 3 times 3, which is 9. I hope you've learnt a little bit in this video about expanding one pair of brackets and two pair of brackets. In coming videos we will look at more complicated expansions. Until then, bye bye.